Hello everyone. Today in this video we are going to solve a Leetcode problem named single number 3. So let us read the problem statement and see what it says. Given an integer array nums in which exactly two elements appear only once and all the other elements appear exactly twice. Find the two elements that appear only once. You can return the answer in any order. Okay. And you must write an algorithm that runs in a linear runtime complexity and uses only constant extra space. Alright, so we will be given an array nums, and in that array we are going to have all the numbers appearing twice except for the two that are going to appear only once. So we have to return those two numbers that are appearing only once, and we have to do it in linear time and constant space. The other constraints are the number of the numbers are going to be between 2 to 3 into 10 to the power 4, that is the size of the array, and every value of the array is going to be in between minus 2 to the power 31 to 2 to the power 31 minus 1. Okay, and this is the same that each number will appear twice, only two numbers will appear once. Okay, so let us see how we're going to solve this, and let me take this example. Right. Okay. So there are many ways to solve this problem, but the constraint that we want the solution to be in big O of n time and big O one space specifically refers to one solution. So let me first tell you what other solutions are. So one way that we can do is we can use sorting. We can sort the numbers out and then iterate through that array and see which number is occurring only once and which are occurring twice. So using sorting, we will get constant space, but the time complexity will be big O n log n that we do not want. And the other solution that we can think is using hashing. So using hashing, we will get a linear time solution, but the space is going to be more. So then it is going to be big O of n space. So this is not what we want. We want big O n time and big O one space specifically. So what is the other method to solve this? The other technique that we are going to use is bitwise operators, especially bitwise XOR operator. So how what property of bitwise XOR that we are going to use here? That is, if we take XOR of two numbers, the same number, it will give they will negate each other and result in 0. So if we take 2 0 2, this will give us 0. And the other property that we are going to use is I will tell you how that is that to find the rightmost set bit. Okay, these are the major operation that we are going to use. So what is the approach? First, we will take the XOR of all the elements and store in a variable. Let us call it x for XOR. So what will happen, every number that is repeating twice will negate each other, and the numbers that are occurring only once will be the remaining ones. So if we see in this array, 1 and 1 will negate the other one, 2 will negate the other two. Only these two numbers will be remaining, and x will be containing 3, 0, 5, and everything else will become 0. So 3, 0, 5 is going to be 101, 11. This will give us 6, right? So we got 6 in x, but we do not know what are the values of the two numbers. So to know that, we will have to find a way to differentiate between the two numbers, and then in another iteration, like this was the first iteration, and in another iteration we will differentiate between those two numbers and return as an array in our function. So the easiest way is that we can take any set bit from this XOR value that we have got, and use it to differentiate between these two numbers. This is another XOR property that we are using, that is for 0, 0, 1 will give us 1. So whenever, and 1, 0, 0 will give us 1. So whenever we have 1, that is set bit is 1 in the x value, that means the two numbers are not having same value at that bit position, right? That if we see here, 1 is having 0 and 1 is having 1. So based on this condition, based on this property, we can differentiate between these two numbers. So that is why we are using rightmost set bit here. So we will fetch the rightmost set bit from here and use it to separate these two numbers, basically all the numbers, into two groups, and I will show you how our answer will be fetched. So to get the rightmost set bit, we will use a formula a and minus a. Minus a is basically 2's complement of a number. You can see and learn about it on Google, what is 2's complement, and figure out what is happening here. Otherwise, let me know. I will answer it in queries. And after getting rightmost set bit, we have a way, like we can call it a mask. This is a mask that we can use to separate the numbers into two groups. So in the second iteration, we are going to use this mask. That is, we will take nums at I and take AND with this mask. And if we get 1, if we get 0, we will store it in another variable named a, and if we get 1, we will store it in b. So we will take the XOR of all the numbers giving 0 in a, and XOR of all the numbers giving 1 in b. So what will happen, every identical numbers, that is if we have 1 and 1, so these two numbers will either come to this group, that is to a, or they will come to this group. Doesn't matter which group they go to, they will eventually become 0 because they will neutralize each other. And the only concerned numbers will be 3 and 5. And we know that 3 and 5 will not go to the same group, because this is the property that we have used, right? 3 and 5 is the XOR that we have got in the first iteration, and based on the XOR property that they are different, they are not same at that bit position, we fetch that bit position, and based on that we are dividing into two groups. So either 5 will come here or here, But if 5 comes here, 3 will not come here. 3 will go there in B, right? So this way we will get two numbers into two different groups, and we can simply return A and B in an array in our function. So we have not used any extra data structure that depends on the input. So we can say that space complexity is constant, right? Space is constant, and we have used two iterations. So we can say that one is big O n, one iteration take big O n time. So eventually, if we say that it will become 2 big O of n, so we can neglect this 2. We can say that this is a linear time, right? So I hope you understood the approach. Now let us jump to the code and see how we're going to implement that. I'm going to use C++. Okay, so first let me create a variable x where we are going to store the XOR of all the numbers. And in first iteration, I will simply take XOR of these numbers. X XOR is equal to num set I. After taking XOR, I need to fetch the rightmost set bit, and I will call it mask. And mask is going to be equal to xn minus x, right? And based on this mask in the second iteration, we are going to make two groups. So let me call one as A and another one as B. Okay, so I will take AND with the mask with every number. If I get 1, that is non-zero value, then I will put it in, let us say A XOR is equal to num set I, and else I will put that number in B. After this loop, we will get the two numbers in A and B, and in the end we can simply return A and B in array. Let us run it and see if it is working. Okay. Fine, now let me submit it. Okay, we have an error. Okay, so if we have this value, and if we take 2's complement, then it will become okay, we cannot use that. We have to use long here. Let us use long here, and mask will be in integer. Let us use long here. Okay, let me submit it. Yeah, it got accepted. So I hope you understood the solution to this problem, and if you have any doubts, you can ask in the comments.